Hi guys, today I wanted to show you something different. So welcome to my channel. Today we are going to show you some 3 projects that I've been working on to level up and switch roles into systems engineering. So I've been writing web dev projects for some times now, I think 3 years, and it just kind of got routine and started becoming boring in quotes. So I wanted to venture into something interesting, and I found systems programming really interesting. So a lot of concepts, computer science concepts, are always abstracted away when you are writing web APIs, because most of the time we use libraries that are written by other people, and we don't actually get to experience the low levelness of software when you are doing web development. So I figured out maybe jumping and trying to learn systems development would come a long way. So I got a book. Yeah, so I did get this book. It's titled Systems Programming Essentials in Golang, and I've just been going through it, trying to understand how Go can come in handy here, because Golang is the language I'm most comfortable with, and I wanted to do this in Go. So project number 1, I was so for project number 1, I decided to write a distributed cache. So every time you use things like memcache, you use things like Redis, but how do these things work under the hood? So, and how do we distribute this? So basics of distributed systems, you can choose to distribute 2 things. Either you distribute the compute. An example would be, let's say you have a large CSV file and you want to get the average of maybe a cell. You could split it into 5, send the data to different nodes, they compute it, and then they will send it to the master node to compile the results and do the different computations. That's when compute. But then you can also distribute the data. So in our application, we've decided to distribute the data. So our application, I wrote this, so it will be a multi-node cache with automatic data distribution. We are going to it uses a hash ring. This is the implementation of our hash ring. It uses a hash ring to compute which node, what data goes to which node, and all that. And all in all, our whole system, the nodes are aware. So let's say I send a GET request to node A, but the data is not in node A. It knows where it is. It will retrieve it and return it. An example here, I will run server 1 and server 2. So in my makefile, I can run server 1, server 2, and server 3. So let me just make server 1 and then open another terminal, and then make server 2, and then I will open, we have another terminal here, make server 3. So we have 3 servers running. So when you come to my Insomnia, we are going to send a set request to server 8061, localhost 8061, and we are setting key 01 and value Mahinya. So let's set, it is set, and then we want to get from server localhost 8060. So let's send, we get the value. Another thing, let me come here and change this to 02. Let's set it on 62. and then we will try and retrieve from 60. So our key was 0 2. You see, yeah, so our server, any server that we send, we can send a set request to any server. It will be replicated. The hash ring will help in distributing the data across the nodes, but then you can submit a GET request from anywhere, and you will be able to see what's going on. So yeah, that is that for that. Another project I've worked on is the Chip 8 emulator. So this works. So Chip 8 is an interpreted programming language. It was made in the 70s to help play games on systems that were available then. So it has a 4 kilobyte of memory, and then 16 8-bit general purpose registers. You can read about this. So I built this, and it has here is a game, a Chip 8 ROM. I think we can, if we go online and search Chip 8 ROMs, yeah, you can find this here. Games. All these are games, are Chip 8 games. So let's see if we can download one randomly and then play it in our game. I don't know how Figures is played, but we are we will load it on our emulator and see it in action. So what we do here is create a makefile. Touch. So we can create one for airplane. And how will it be? It will be at go run main.go, and then we will pass the ROMs / so let's see, make airplanes. Yeah, so you can see from the screen our game is loaded, and I think we can try and drop bombs. I don't know, with letter S. Yeah, letter S helps you drop the bomb. So as you can see, that's our second project. And yeah, let's go through the code and see what's going on. So this is our computer. The Chip 8 struct is basically our computer. As we said, the Chip 8 has a memory of 8 kilobytes, 16 8-bit registers, an index register, program counter, and then stack for subroutine calls. So we set a font set for it, and then this is just a struct to initialize. This is how we load the ROM. So we are checking if the ROM can fit inside the memory. So we check if it can fit inside the memory. If it doesn't, we truncate and only fit what could fit. Yeah, that's it. It was an interesting project, a lot of learning on low-level stuff. Introduced me to this Go library called SDL. It's for the graphics and all that. Yeah. Our last project is this serverless project. So what are we doing here? So what I was trying to do here was, like, you've interacted with lambdas and all that, and functions as a service. So how are they made? So you submit your code, it gets executed in an isolated environment, and then the output is returned to you. So this is what my serverless does. So I could demonstrate how it works. So we have this image processor.zip and test.zip. So these are Python zip files that we can submit. Let's look at the make file. So it will run on port 8080. This is the server URL, and then the zip file we are submitting is that, and then the function ID. So this one changes every time when you submit. You can let's see how we submit. So how do we submit? We submit the zip file to the server URL stroke API/submit. Let's make submit. So right now, no, I don't know if the server is running. Yeah, the server is running. So as you can see, we've submitted our image processor.zip. So this is the function ID, and this is the image ID that has been created. So it has been deployed successfully. So let's say we want to execute the function that we zipped and sent. And the reason we are zipping and sending is Python files often need to, like, this is the Python code we are sending, we are zipping, and then this is the text requirements.txt file that is going to be used to install the requirements and then execute the Python file. So for this, the languages supported Golang and Python. So I could extend it, but I think the basics of what I wanted to learn were done. So when I come to my make file and then I replace this function ID, now I can execute. So execution, you send to the server URL parameter function ID. So let's see, make execute. So it executes that, and all this gibberish you're seeing on the screen is an image encoded. So this image that we submitted here, we've changed it to black and white, and this is now the image encoded in base 65. So this is my third project. So a lot of learnings from here, like when you come and look at the Docker file. So how are we creating Docker files on the fly? And this thing is making a lot of noise, and I don't know if this is a serverless platform. So all the code that I've written, I'm going to share the repositories for all this that I've shared so that you can take a look at them. And maybe you're asking yourself, where can I get inspiration for projects? There's this guy on LinkedIn. There's this guy on LinkedIn. Let's see, coding challenges. Yeah, so I found this guy on LinkedIn. So as you can see, they normally use tools. There are step-by-step instructions for you to build these tools that you always normally use, like the diff tool. You can build your own shell or load balancer. This was interesting. My next project, I will be building a load balancer for the cache that I've shown you, and then WC tools, JSON parser. This is also a very interesting one. And yeah, that's it. If you found this useful, please share with somebody who will also find it useful and enjoy the rest of your day. Don't forget to like, subscribe, as that comes. I will really appreciate that.